Hi there everyone. Welcome to the video lecture series on complex variable and analytic functions. Now let us continue our discussion of solving of questions of different types. So here I take up the second question to show that function f of z equals to z cube is analytic function and find its derivative. Now this question would like to give a small hint or just a prior thing that the derivative of z cube is going to be the ordinary way, the way we calculate the derivative. The answer is going to be 3z square, but there is a procedure in complex variable or complex analysis topic. There is a procedure how we get that. Later on we will see that we will consider that this procedure is already at the back of our mind so that we can immediately solve it, but this is what entirely how the process is going to be. Let us see the whole process now. So we take up for the answer now. So the function f of z is equals to z cube is given to us, so we consider this. Consider f of z is equals to z cube. Now we have the step number 1 over here. So step 1 is put f of z is equals to u plus iv, okay, u plus iv, and z is equals to x plus iy. So when we do that, we get over here u plus iv is equals to x plus iy the whole cube. Now we try to expand this. So the expansion of a plus b the whole cube will be applied. So it will be x cube plus 3x square times iy plus 3x times iy square plus iy cube. On simplification of this further, we will get x cube plus 3x square y I, and now here we will have 3x y square I square. I'll just write it like this, and then it would be I cube y cube. So this will give you x cube plus 3x square y I, and here we will have minus of 3x y square and minus of I y cube. The reason here being, how did we get that? The reason I would like here to write it is, the reason is I square is minus 1 and I cube is minus of I. Okay, so we have that, and now we collect the real part and the imaginary part. So all the terms which are apart from I can be collected. So they are x cube minus 3x y square, and then we collect the term with I. So if we see there, then it is 3x square y minus y cube. Okay, so we had in the LHS as u plus iv. So now using that same pattern, we compare the real parts. So real part is u equal to x cube minus 3x y square, and the imaginary part v is going to be 3x square y minus of pi cube. that that is what we have. Now we go for the step number 2 to check how to write for the Cauchy-Riemann equations. Okay, so step number 2 is to check whether the Cauchy-Riemann equations, to check whether CR equations are satisfied or not. Okay, so let us see that. So the first thing is that we are going to do the calculation of all those partial derivatives of u and v. So let us do that. So we have first derivative we will calculate. So consider ux, u suffix x meaning it is dabba u by dabba x. So the partial derivative of the term x cube minus 3xy square is to be calculated, and that is going to be 3x square minus 3y square. That is what is the partial derivative with respect to x for u. Now also let us calculate u suffix y. So when that is calculated, it is going to be 0 minus 3 times x multiplied by 2y. Okay, so that will give me minus of 6xy. Now we go for calculation of v suffix x. So v suffix x is nothing but dabba v divided by dabba x. So let us calculate that. So that is dabba by dabba x operating on 3x square y minus y cube. So when we have this, it will be, so the derivative when we calculate here, we will get, it will be 6xy minus 0. So that is gone. Okay, so that is the answer over here. And we also calculate for vy, right? So vy is dabba v operated on dabba, sorry, dabba by dabba v over dabba by dabba y. It's going to give you, when we calculate this, it is 3x square, and then it is minus of 3y square. Okay, so that is the partial derivative. So now we can label them quickly. So once we label them here, and we get from, okay, 1 ux and vy, ux and vy are same. From 1 and 4 we see here that we get u suffix x is equals to v suffix y, and from 2 and 3 we get is that, yeah, u suffix y is negative of v suffix x. Okay, that is what we get. So finally we say here that therefore CR equations are satisfied. Okay, that is working. Now how do we write about the continuity? So now let us go about that. So continuity we have to deal. So we write here that way. So our functions are ux equals to, here ux is 3x square minus 3y square. That is what we have. And uy, u suffix y, I mean to say, is nothing but minus of 6xy. Okay, that is what we see here. So we mention here that that x square, y square, x and y are polynomials, okay, and polynomial are continuous, are polynomials, or you can write polynomial functions, okay, that would also do. Polynomial functions are continuous. We take this result for granted for some time in order to tackle the concept, okay, because this topic is an advanced topic from complex analysis. So at that time students are obviously having a great background regarding continuity, and the concepts can be immediately fetched from the previous knowledge. So right now we can take it away directly, that x square, y square, x, y are polynomials and polynomial functions are continuous. Therefore u suffix x, u suffix y, v suffix x and v suffix y are continuous. Hence f of z, which is z cube, is analytic function, is is an analytic function. I'll just say is an analytic function. Okay, so that is what we get. Now in order to find the derivative, okay, so to find f dash of z, let us see how to go about that. It is going to be, the formula was f dash of z is u suffix x plus I v suffix x. This formula can be used. Now this formula ux is 3x square minus y square, right? 3 can be taken common, here we have written up, okay, and ux equals to vy, and uy is minus of vx, right? So vx is going to be, over here it is I times minus of uh, it is vx is positive, right? Vx is positive 6x, so here it is going to be 6xy. This is the value of vx, okay, so vx is over here. Now we take 3 common. The moment I take 3 common, inside the bracket I am left with x square minus y square plus 2xy, and there is an I also from the term. Okay, now what to do? This minus y square, this is very important step. I'll just put a star in the next step, see. So how it is done, f dash of z further can be now treated like this, 3 times x square, and now this minus which is there is now can be written as I square. Minus of y can be written as, minus of y square can be written as minus of y square is same as minus 1 multiplied by y square, and this minus 1 can be treated as I square times y square. Okay, so this is what you get. So I times y square plus 2xyi This is what we get. Now if we observe, this is nothing but the very basic thing. Okay, I'll just put this side, and that this is nothing but basic expansion of a square plus 2ab plus b square, which is equals to a plus b the whole square. Okay, just some terms are shifted here and there. So if we do that way, then what do we get now is 3 times x plus iy the whole square. This is what we get. And therefore, and now we know that x plus iy is z, so this is 3z square f dash of z. That is what we have obtained. Okay, so this is how it is handled over here. Now very easy way out it is, and very important all throughout. We can do this kind of questions. So this was one very important question. You can try on your own the same uh, kind of questions. That is, let me give you some practice problems so that you can try. Is try you can try you can try these kind of questions for yourself. That is, I'll write here, try yourself. Okay, so these are the two questions. The derivative are very straightforward. For the first question you will get the answer 2z, the second one you'll get 2z plus 1. Okay, so that's very straightforward and very much similar in line with what we have done here. If you do not get, let me know in the comment section. I'll help you out with another video lecture possibly on those two. So this was my second video on the question solving of analytic function. I hope you liked the content and you enjoyed and you understood the concept. Please hit like button, do share it with your friends, those who find this topic useful, and let me know any doubt or your feedback in the comment section. Till then, keep solving good amount of mathematics. Thank you. I'll see you in soon in the next video lecture with a new question.